Hello everybody. This is lesson 3 of the lecture Macroeconomics. We will discuss slide 60 to 79 of chapter 1, Introduction to Macroeconomics. We start with a discussion of the difference between GDP and disposable income of households. Let's begin once again with the definition of GDP. It is the market value of all goods and services produced within a country in a given period of time. Consequently, GDP reflects the production potential of a country. There are, however, problems. For example, market potential analysis, where not the production potential but the purchasing power of the population of a country is in the center of interest. It is evident that there must be a link between production potential of a country and the purchasing power of its population. But it's also evident that there are differences. Where exactly are those differences? The purchasing power of the population of a country depends, of course, primarily on the income of the population. The income of the population differs in several points from GDP. First, GDP does not include income of inhabitants earned abroad in other countries, and GDP does include income from foreigners earned within the country. This type of income can be labor income as well as capital income. For example, a German household may own stock from American stock companies and receive regular dividend payments from the United States. So this capital income is, of course, part of total German household income, but it is not part of German GDP, since German GDP measures only production which takes place in Germany. So that's one difference we have to deal with in the following. Another difference is GDP does include capital depreciation. Since depreciation corresponds to capital goods that are consumed in the production of other goods, it cannot be part of household income. A third problem is the fact that a part of GDP flows to the government in form of taxes. Household and companies pay taxes to the government. Hence, this part of GDP too cannot be part of household income. Therefore, the following adjustment of GDP does make sense. We start again with gross domestic product at market prices. We first subtract depreciation, physical depreciation of capital goods used in production. If we subtract this aggregate from gross domestic product, we receive net domestic product. So this means that the word gross in the expression gross domestic product refers to depreciation. If we subtract depreciation, we talk of net domestic product, or the shortcut would be NDP. Next, we subtract indirect taxes, which means mostly the value-added taxes paid by private companies to the government, and we add all the subsidies private companies receive from the government. So this is, in a sense, the net tax burden private companies pay to the government. If you do this, we receive an aggregate which is called net domestic product at factor prices. So here we use the word factor prices to indicate that we have now a value of GDP without the tax payments, the net tax payments by private companies to the government. The expression at factor prices indicates that this NDP aggregate measures NDP not at the market prices final users have to pay, but at the prices which reflect the production factor costs before tax. The next modification we undertake is we add income of inhabitants abroad. As already mentioned, this can be labor income from inhabitants of Germany which work, for example, in France or in Luxembourg, or it can be capital income from German households that are paid to them by governments or private companies in foreign countries, of which German households hold assets like fixed rate securities or stock. If we add this aggregate as a component of household income, we have to subtract the part of GDP that flows as income to foreign households. So we subtract income of foreigners within the country. Again, this income can be labor income from foreign households which work in Germany, or it can be capital income from foreign households which hold assets of German companies or the German government. If you do this modification, we receive an aggregate which is called net national income at factor prices. So we have now moved from net domestic product to net national income. Next, we have to take care for the net tax burden households pay to the government. This is basically direct taxes, which means taxes on labor and wealth income. That is something we have to subtract, of course, and then we know that a couple of households receive social transfers from the government, for example, social benefits or child benefits. Another component which is subtracted here are interest payments on consumer credits by households. It's a bit questionable whether this makes too much sense. I will comment on this later. If you do this, however, then by the official internationally standardized definition, we receive disposable income of households. So now we have calculated our way down from gross domestic product to disposable income of households, the money that households hold in their pockets by the end of the day. What we need in the following is the difference between gross domestic product and disposable income of households. The name of the in-between aggregates, which I have used here, are not important. So I have cancelled them in the lecture notes. I have also cancelled the name of or the expression interest on consumer credits because it's questionable whether this makes too much sense to subtract this number to receive disposable income of households. The original idea is that these interest payments have to be subtracted because they are, in the short term at least, not available for purchases of goods and services, other goods and services. This is a little bit arbitrary, since the same holds for rent payments of households, insurance fees, for example, and other regular payments which are not subtracted. So it's no big problem and certainly no economic mistake to neglect these interest payments on consumer credits. Okay, but the difference between GDP and disposable income of households is important and you should try to remember it. As this decomposition shows, disposable income of households is the aggregate that should be used for market potential analysis. It is therefore often simply called purchasing power. In many countries, it is available on the regional level. In Germany, for example, it is available even on the level of districts, in the sense of Kreise und kreisfreie Städte. Only if other numbers are not available, GDP should be used for such kind of analysis. If, however, possible, one should always try to correct GDP numbers towards an aggregate that comes closer to disposable income of households. If you take a look on the distribution, the regional distribution of disposable income of households in Germany, based on this map, we can discover quite strong structural differences, especially between East and West Germany. As this map reveals, there are strong structural differences, especially between East Germany and West Germany. Most East German districts are colored with bright or somewhat darker yellow, indicating an income bracket below 16,500 euro disposable income per year. This reflects the still prevailing economic difference between East and West Germany. Within West Germany, there are also strong differences observable. For example, high income clusters are in districts around Munich, Stuttgart, Frankfurt, the Ruhr area and Hamburg. These districts are colored by deep purple, indicating an income bracket above 25,500 euro disposable income per year. These regional clusters correspond with higher income providing industries like aerospace and computer industries around Munich, motor industries around Stuttgart, financial industries around Frankfurt, some remaining industrial centers in the Ruhr area, and transportation industries and media companies around Hamburg. Pforzheim is in the income bracket from 16,500 to 18,000 euros per year. This indicates a relative weak position among the West German districts. Finally, I would like to address the question whether GDP can be used as a measure of welfare. Welfare is a somewhat, let's say, cloudy expression. However, commonly welfare means something like economic well-being of people. Certainly, economic well-being depends stronger on disposable income, but GDP. Therefore, disposable income is certainly a better indicator for welfare. There are, however, other objections against the usage of GDP and also disposable income as indicators of welfare. A couple of them are discussed in the following. The first problem I would like to discuss has to do with the problem of non-market production. As already seen, GDP measures only goods and services which are traded over markets. Home production, for example, the education of children, private cooking or housekeeping, and of course subsistence agriculture in developing countries is not captured, even though it does of course affect the welfare of people many times in an important way. So this is one problem where we can certainly say GDP cannot be a perfect measure for welfare. Second problem is captured by the key term leisure time. In a country, for example, where people have a strong preference for consumption and hence for a high income that makes high consumption possible, GDP will be larger than the GDP of a country where people have a strong preference for leisure time. Nevertheless, people of both countries may have the subjective impression that they share the same level of welfare. This figure shows that there are indeed significant differences in the number of working hours per year across these countries. For example, the United Kingdom has a number of working hours per year which is roughly 200 hours higher than in Germany and 250 hours higher than in France, displayed here. So if labor productivity and everything else were the same in these countries, GDP and also disposable income per capita would be higher in the United Kingdom. Higher income allows for a higher consumption level. However, the higher subjective welfare from higher consumption level might be completely absorbed by the lower leisure time for workers in the United Kingdom, such that they experience the same welfare level as countries with a lower per capita GDP. So this is a second problem that emerges if we use GDP as a measure for welfare. Another problem with the interpretation of GDP as a measure of welfare is related to environmental goods production. Environmental protection consumes intermediate products. For example, air cleaners for the purification of contaminated air, or clarification plants for the purification of wastewaters. These intermediate products can therefore not be used to produce final goods. The benefits from environmental production are not sold over markets and therefore not captured by GDP. However, if instead final products which are sold over markets were produced, this would be captured by GDP. Consequently, environmental protection reduces measured GDP, even though the positive effect of environmental protection on welfare can be larger than the negative effect of a lower GDP on welfare. A fourth problem I would like to address here is the problem of income distribution. A high GDP might come along with a very uneven distribution of income between the members of a society. Therefore, an analysis of economic welfare should not only reflect the level of GDP, but also take care about measures of income distribution. The Indian economist Amartya Sen has pointed to a further problem in measuring human welfare. Disposable income measures only purchasing power available to people. What people can do with this purchasing power does, however, also depend on other factors like personal health state, personal education level, access to information, legal framework, or political freedoms, and so on. Therefore, the same level of income can grant a person more or less implementation options, which Amartya Sen calls capabilities, depending on all these mentioned factors. To make two examples. First, a severely handicapped or sick person can certainly enjoy his income level not in the same way as a healthy person. Another example is a person with a low education level or restricted access to information will typically know less options how to spend income than a well-educated person or a person with full access to all relevant information. Consequently, the same income level can go along with quite different levels of attainable capabilities. Capabilities are, however, hard to measure since they depend on soft factors which very often lack a statistical coverage. Nevertheless, some of these factors, which are likely to have a significant impact on capabilities, are available. for example, life expectancy or the average education level of a population. Therefore, the United Nations have started a project where every year since 1990 a so-called Human Development Index is calculated for 169 member countries of the United Nations. The Human Development Index is calculated according to the following definition. I explain the Human Development Index based on its formula. You do, however, not need to learn this formula by rote. Okay, the Human Development Index is a geometric mean of 3 components. The first component is per capita gross national product. As we have seen in the section before, gross national product equals GDP plus income of inhabitants abroad minus income of foreigners within the country. GNP is selected for the calculation of the Human Development Index because GNP is closer to disposable income than GDP, as we have just seen in section 1.3.4. Theoretically, disposable income is to be preferred compared to GNP. However, disposable income is not known for poorer countries where statistical offices have not the financial means to gather the necessary data. Therefore, the calculation of the Human Development Index refers to GNP. Now, the per capita GNP of all 169 countries is scaled between 1 and 100. The country with the highest per capita GDP receives the value of 100, while the country with the lowest GNP level receives the value 1. All other countries are grouped in between this interval according to the rule of proportion. So the resulting number is an index number between 1 and 100 for every country. Okay. The same procedure is applied to the average life expectancy and the education level measured primarily by the average number of years spent in schooling. Now, the calculation of the Human Development Index is based on the geometrical mean of these 3 index numbers: GNP times life expectancy times education level. From this product, the third root is extracted such that we receive the geometrical mean. The calculation of the geometrical mean weighs smaller numbers for one of the 3 components stronger than the arithmetical mean. To calculate the arithmetical mean, we would just add up the 3 numbers and divide them over 3. The fact that the geometrical mean weighs small numbers higher than large numbers can be easily seen if you assume that one of these numbers would be 0. Then the whole product would be 0, and the Human Development Index for a country where one of these three components would be simply 0 would also be 0. The resulting number following this formula will also be an index number between 1 and 100. So this is the way how the Human Development Index is calculated. Now we will discover how we can interpret the Human Development Index. This diagram displays the relation between the Human Development Index on the abscissa, the x-axis, and the ordinate, the y-axis. As is obvious, there's a strong positive correlation between both numbers, which means the higher per capita GNP, the higher also the Human Development Index. If we rank the countries according to the level of per capita GNP, the resulting ranking is by 95% the same as if we rank the countries according to the Human Development Index. In other words, only 5% of the countries has a different position. The rank correlation coefficient used here to measure this correlation is explained with the help of the following numerical examples. This is only a numerical example. You do not have to learn the formulas used here by heart. So basically we have two country lists here, list 1 and list 2, with 3 countries. In both of these lists, the ranking of the 3 countries is exactly the same. In list 1, country A is on the first position, country B on the second, and country C on the third position. In list 2, it's just the same. If we apply now this formula of the rank correlation coefficient to both lists, the resulting number is 1 or 100%. In other words, if the ranking of two lists is exactly the same, the rank correlation coefficient provides us a value of exactly 100%. In the second example here, country list 2 is just the opposite of country list 1. In country list 1, country A is on the first position as before. In country list 2, country A is on the third position. Now, country B is in both lists in the middle, while country C is in list 1 on the third position, and in country list 2 on the first position. If we apply now the formula for the rank correlation coefficient to these lists, the value is exactly minus 100%. So if two lists are just opposites of each other, then the rank correlation coefficient signals this with a value that is just equal to minus 100%. Now let me make a third example, a less extreme example, somewhat in between. Here we have again the same country list 1. Now I've modified somewhat country list 2 such that the position, the ranking of country A and B is exchanged compared to list 1. In list 2, country A is now on the second position, while in list 1 it is on the first position, and in list 2 country B is on the first position, while in list 1 it is on the second position. Country C is in both lists on the third position. So it's not completely different, but somewhat different. And if we apply now the formula for the rank correlation coefficient to these lists, then the resulting number is plus 50%. So the plus signals that there is a lot of correspondence, a lot of correlation, but the fact that it is significantly smaller than 1 indicates that there are some differences in the ranking of at least some countries. So this is the way how we can interpret a rank correlation coefficient. It measures the degree to which two lists resemble each other or not. Now, it's quite a useful measure, which I've also used to calculate the correlation between per capita GNP of the same countries as before and the life expectancy in these countries. Life expectancy now here expressed on the abscissa. Here it is also observable that there is a strong positive correlation between both numbers, life expectancy and GNP per capita. So if GNP per capita is larger, then in general life expectancy is larger. If we measure again the rank correlation coefficient, we receive here a value of nearly or somewhat above 85%. So this indicates there's a strong positive correlation, and the fact that this number is not too different from 100% indicates that there's a lot of similarity between both rankings. The ranking according to life expectancy and the ranking according to per capita GNP. The difference is only on a margin of about 15%. That is not extremely much. If you now compare the degree of correlation between per capita GNP and mean years of schooling as a measure of the education level of these countries, then the correlation gets somewhat weaker. This is now more a cloud than a string of pearls, but nevertheless it is clear that there is a positive correlation. So the higher per capita GNP, the higher typically the mean years of schooling, the higher, in other words, the average education level of these countries. And if we calculate now the rank correlation coefficient, then we still receive a value of nearly 76%. So the difference in the ranking of these countries according to per capita GNP or mean years of schooling is only about 25%. So in other words, there is not that much difference. Both indicators are quite closely related with each other, positively correlated to each other. Okay, what does this tell us? Well, I think these diagrams show that GNP typically contains a lot of information about life expectancy and the education level. Countries with a high level of GNP or GDP should typically also have a high level of life expectancy and education. Consequently, if life expectancy and the education level contain information about human welfare, so will GNP or GDP. Even so, GDP or GNP is not defined to measure human welfare. They should nevertheless contain information with respect to human welfare. Okay, so much for this lesson. We have now finished Chapter 1, Introduction to Macroeconomics. In the next lesson we will start with Chapter 2, The Long Run Development of Economies.